But first things first, I want to think about some of the geometry, some of the operations which we can do on complex numbers, and more importantly, we can need to think about what that means from a geometric perspective. Okay? Because like complex numbers are just numbers, right? But so far, you've always been thinking of numbers as one-dimensional things. Okay? In other words, a number which appears on the number line. Okay? Whereas now, numbers are two-dimensional. Okay? It's just you've never really seen that two-dimensional element until now, until the complex numbers, the imaginary numbers came to life. Okay? So let's think about what happens when you multiply, when you subtract, when you add real numbers, and then we can think about what happens when we subtract, add, multiply, whatever, complex numbers. So I is equal to the square root of -1, right? Let's have a think. What would I squared be equal to?
I squared would be equal to
Why is it -1?
Because the square root and the square cancel out.
Good. You're literally saying take a number, in this case -1, square root it, but then immediately square it. Okay? The inverse functions, they undo each other in this case. So therefore, the I squared should be equal to -1. Happy with that? What about I cubed? Was it? Not quite. Yeah, you can think about this as I squared times by I, can't you? Yeah, because I cubed, I squared times by I to the power of 1. Well, I squared is equal to -1. So what's -1 times I? -I. Happy with that?
Mm-hmm.
What about I to the power of 4?
1.
Okay, so we can think about this as I squared times by I squared. So we think about this as -1 times by -1, which is equal to 1. Perfect. Okay. What about I to the power of 5?
I think it will fluctuate. I feel like there will be fluctuation will go on. You know?
What do you mean by fluctuation?
I mean, let's think like I5 as like I over 4 to I, which will equal to I. And
Okay.
then I2 will be -1.
Right, good. So, if you didn't catch that, I to the power of 5, you can think about that as combinations of things which we've already done.
Mm-hmm.
Okay, so I to the power of 4 we know is equal to 1, and we're just timesing that by I. So 1 times I is just going to be equal to I.
Mm-hmm.
Now, in case you didn't catch this, so let me just write it out again. I guess we didn't do I to the power of 0, but given that I is just a number, right, it's just a number, exactly the same as before, any number to the power of 0 is always 1. Good. Now, what do we say I to the power of 1 was equal to? I to the power of 1 was equal to I. Fairly obvious, it's equal to itself. Okay. What about I squared? What do we say that one was equal to? -1. Good. What do we say I to the power of 3 was equal to? -I. What do we say I to the power of 4 is equal to? 1. What do we say I to the power of 5 is equal to? I. What do you reckon I to the power of 6 is going to be equal to?
-1.
Okay, what do you reckon I to the power of 7 is going to be equal to?
I.
Okay, what do you reckon I to the power of 8 is going to be equal to?
1.
1. Now, why do you think that?
Because we can think like I7 as like I8 as like I mean, there's a fluctuation going on.
There's repetition going on, absolutely. And the repetition is that cycle over and over and over and over and over again. So I to the power of 0 is 1, then it goes negative, then it goes I, then it goes -1, then it goes -I, then we're back at 1 again. Then I, then -1, then -I, then we're back at 1 again. So there's another cycle there. And then the next cycle is also going to repeat again. Does that make sense to everyone? Okay. So we can see this pattern happening. So basically there's 4 things that it cycles through. Okay. So what we can do is visualize this on the screen. Okay. So you can see I to the power of 0 we said was equal to 1. Any number to the power of 0 is equal to 1. And you can see I've represented that with a dot. Okay. At 1. Make sense? So that number there I've just represented as a dot. Now if we multiply by I, watch what happens. So we said I to the power of 1 should be equal to I. In other words, we multiply it by I, we jump up there to I. Does that make sense? Mm-hmm. What happens if we multiply by another I? We jump down here to -1. What happens if we multiply by another I? we jump over here to negative I. And then we multiply by I again, we get back to I. Multiply by I again, we go back to 1. Multiply by I again, we go to negative 1. Can you see, every single time we multiply by I, we are basically rotating through 90 degrees anti-clockwise. Does that make sense? Okay, so it's the first kind of geometric idea which I want you to get in your head. Multiplying by I, so any number, if you multiply by I, that corresponds to a rotation 90 degrees anti-clockwise about the origin, whatever you want to say. About 0, 0. Okay? So we're starting to build this idea that if we multiply by complex numbers, imaginary numbers, complex numbers, okay, we're getting this idea that there's a rotation which is starting to happen. I think this is really cool, and we're going to play on this idea a little bit more.